Section 6.2 covers many different objectives on the real numbers, operations, properties, and applications. It's on operations like addition, subtraction, multiplication, and division of signed numbers. Then the very important topic, the rules of order of operations. And then number 3, to identify and apply properties of addition and multiplication of real numbers. And then determining the change in investment in meteorological data using subtraction absolute value. We'll be doing some other examples on that. So we begin with the operations of real numbers. And again, most of it will be a review for you because I'm sure you've seen most of it. And for example, the result of adding two numbers is their sum. And the numbers being added are called addends or terms. The word addends is not used very often, but once in a while you see it, like in this book. I may use it also once in a while. The use term is perhaps more common. So here's the official definition for adding real numbers. When we have like signs, we add two numbers with the same sign by adding the absolute values, and the sign of the sum, either positive or negative, is the same as the sign of the two addends. Now when the signs are unlike, in other words we add a positive and a negative number, when they have two different signs, by subtracting the lesser absolute value from the greater to find the absolute value of the sum. So the sum is positive if the positive number has a greater absolute value, and the sum is negative if the negative number has a greater absolute value. And so now since most of you are probably using calculators for adding and subtracting numbers, this is probably not all that important to you, but sometimes calculators work differently, how you input the numbers, especially when it comes to signed numbers. So this could be of great value to you to make sure that you come up with the correct answer, even if you do use a calculator. So in the first case, here for finding each sum for A, so for A we have -6 plus -3. We write it as -6 plus 3, and it would be -9. And for the B part, -12 plus -4, -12 plus -4, that would be equal to -12 plus 4, or -16. And for the C part, 4 plus -1, that is equal to 3. And D, -9 plus 16, -9 plus 16, that's equal to 7. For E, we have -16 plus 12, -16 plus 12, or -4. And for F, we have -4 plus 4. That's equal to 0 because -4 is the additive inverse of 4. And the number plus its additive inverse is always equal to 0. Next is the definition of subtraction. And that is for all real numbers A and B, A minus B is the same as A plus the opposite of B. It's a very important identity here, and it's important to realize that in many cases when we do these kind of operations, I will point that out, that these two presentations are the same. So we change the sign of the subtrahend and add. And then a general agreement is that the phrase the difference of A and B is interpreted as A minus B. Again, this is important when it comes to word problems or application problems. So the difference of A and B is interpreted as A minus B. It seems almost counterintuitive because the and seems to imply addition. But it's the difference of A and B that is interpreted as A minus B. Very important little detail. So here we're to find the difference between two numbers. So for A, 6 minus 8 means 6 plus the opposite of 8, and that is equal to negative 2. Then for B, minus 12 minus 4 is equal to minus 12 plus the opposite of 4, and that's equal to minus 16. And for C, we have minus 10 minus negative 7, so it's minus 10 plus 7, or negative 3. And then 15 minus negative 3 for D, 15 minus negative 3, that is 15, since the double negative, we get 15 plus 3, or 18, as the answer for part D. The next topic is the multiplication of real numbers, and here two cases. Number one, like signs. Multiply two numbers with the same sign by multiplying their absolute values to find the absolute value of the product, and the product is positive. So like signs means the product is positive. When we have unlike signs, we're multiplying two numbers with different signs by multiplying their absolute values to find the absolute value of the product, and the product is negative. So one way to visualize that is to say, okay, a plus times a plus is a plus, and a minus times a minus is a plus. But a plus times a minus is a minus. Similarly, a minus times a plus is also a minus. So this may be a good way to remember how that works with the signs in case of multiplication. In the next three exercises, we have to find the product. So for A, minus 9 times positive 7, so it means the product will be negative, so it would be minus 63. That's the answer for part A. And for part B, we have a positive times a negative, so that answer will be negative, and that is equal to minus 70. Here we have like signs for part C, so 8 times 4 is 32, and that is a positive because the signs are the same. Next, we'll be talking about dividing two numbers, and so the result of dividing two numbers is their quotient. So whenever you hear the word quotient, it means we are talking about dividing two quantities. In the quotient A divided by B, or written with a fraction bar, A divided by B, where B is not equal to 0, A is a dividend, or numerator, and B is the divisor, or the denominator. You're probably more familiar with numerator and denominator, but dividend and divisor are very common as well. And so for any real numbers A, B, and C, if A divided by B equals C, then A equals B times C. again, this is a very useful identity, and so you may want to remember that. So here's the division definition about the signs. If we divide two numbers with the same sign by dividing their absolute value, then we find the absolute value of the quotient, and then the quotient is positive. And when the signs are unlike, we divide two numbers with different signs by dividing the absolute values to find the absolute value of the quotient, and then the quotient is negative. So in a way, it's like with the multiplication, when we divide a positive by a positive, the result will be a positive. Similarly, when we divide a negative by a negative number, the quotient will be positive. But when we divide a positive by a negative, the quotient will be negative. Similarly, when we divide a negative by a positive, then the quotient will also be negative. So it's just like with the multiplication, when the signs are the same, the quotient will be positive, like the product was positive, and when the signs are opposite, then the quotient will be negative, just as a product will be negative when we have opposite signs or unlike signs. And a general agreement is that the phrase the quotient of A and B means, or is interpreted as A divided by B, either with a fraction bar or with a division symbol. Here are some very simple division exercises. So for A, 15 divided by negative 5, so a positive divided by a negative would be a negative, and so the quotient is equal to negative 3. For B, the signs are the same, so we know the quotient will be positive, and so the answer will be positive 4. Here for C, we have unlike signs, negative divided by positive, so the answer will be negative, the quotient will be negative, and that is minus 20. Next, we talk about a very important subject called, a topic called division involving 0. And that is A divided by 0 is undefined for all real numbers A. So please remember this one very clearly. On the other hand, 0 divided by A is equal to 0 for all non-zero A. So as long as A is not equal to 0, the expression 0 divided by A equals 0. But when 0 is in the denominator, that means it's an undefined expression. And that also means that 0 divided by 0 is undefined, because we have 0 in the denominator. And that's true for all A. It means it includes 0 as well. So 0 divided by 0 is undefined. A divided by 0 is undefined, and 0 divided by A is equal to 0 for all non-zero numbers A. Be sure to think this one through, that you have clarity about it. Next, we have another very important topic called order of operations. And order of operations is really not only applied to mathematics, it's for a lot of things. I can give you some simple examples. For instance, changing the tire on the wheel on a car. Let's say you have a flat tire and the wheel needs to be changed, and maybe you even do it. There's some very specific steps in a very specific order, and the idea is to do it not to create any damage, to do it as safely as possible. Now, the other order of operations, even opening a door, is really an order of operations. You push down on the handle or pull it up, or you turn it and then pull on or push on the door. So unless you do that correctly, the door won't open. So order of operations is really nothing new. Or following a recipe, that's certainly an order of operations. And that gets us a little bit closer to mathematics, because if someone has the same ingredients and follows the order of operations, in other words, follows the recipes, then the outcome will be about the same. And so in mathematics, it's important that when we do calculations, they have a predictable outcome, and that's the reason why there's an order of operations. So here's the order of operations. So if parentheses or square brackets are present, step 1, work separately above and below any fraction bar. Use the rules below within each set of parentheses or square brackets. And you always start with the innermost set and work outward. If no parentheses or brackets are present, apply any exponents. Then do any multiplication or divisions in the order in which they occur, working from left to right. And number 3 would be do any additions or subtractions in the order in which they occur, working from left to right. And if you do this correctly, then your answer will be correct. And if everyone follows these rules, these order of operations, then everyone comes up with the same answer. In other words, we have predictable results. So we have some simple exercises here. Use the order of operations to simplify each expression. So for part A, there are no exponents, so we do multiplication first. 2 times 3 is 6. So 5 plus 2 times 3 is 6 is equal to 11. For the B part, we do have exponents, and that is 3 squared. So we do that part first. So we multiply 4 times, and 3 squared is 9, plus 7, minus, now operations inside parentheses, and 2 plus 8 is 10. And now 4 times 9 is 36. 36 plus 7 is 43. Minus 10 is 33. For the C part, we do the operation parentheses first. So we have 2 times, and 8 minus 12 is negative 4, minus 11 times 4, divided by 5 times negative 2, minus 3. So that's equal to minus 8. And minus 11 times 4 is minus 44. 5 times minus 2 is minus 10, minus 3. So that it means we have minus 52 divided by minus 13, and that's equal to a positive 4. Because we have the same, we have like signs, a numerator and denominator. Now for D, part D, we have minus 6 to the 4th power. So we have minus 6 times 6 times 6 times 6, and that's equal to minus 1296. So note that the base is 6. Not minus 6. Okay, very important difference, because when you look at the next exercise, E is minus 6 in parentheses to the 4th power. And so now we multiply minus 6 times minus 6 times minus 6 times minus 6. So a minus times minus is a plus, a minus times a minus is a plus. So the answer is positive 1296. So be sure to understand the difference between parts D and E. It's really critical. In many applications, you see that you really need to have clarity about the difference in the results as far as the sign is concerned. So here the base is negative 6. And then for the last part, F, so we work inside the brackets first. So we have minus 8 times minus 3 minus, so we work inside the parentheses here, so bracket 4 minus, and 3 minus 6 is negative 3. So that's equal to minus 8 times minus 3 minus, so 4 minus negative 3 is plus 3. So we have minus 8 times minus 3 minus 7. And so we have 24 minus 7, or 17. So that's the answer for part F, 17. Next, we have the basic properties of addition and multiplication of real numbers. And so the properties of addition and multiplication for real numbers a, b, and c, the following properties hold. Number 1 is closure property. A plus b and a times b are real numbers. Now, closure property simply means that the sum of two real numbers and the product of two real numbers themselves are real numbers. They may seem obvious, but there are numbers where that's not necessarily true. So anyway, for real numbers that is true. In other words, when you add two real numbers, you get another real number. When you multiply two real numbers, you get another real number. The other property that's critical is the commutative property of addition and multiplication. And that means two numbers may be added or multiplied in either order without affecting the result. A plus b equals b plus a, and a times b equals b times a. That, by the way, is not true for subtraction or division. It is true for addition, though, and multiplication. The associative properties of addition and multiplication says that a plus b, and then we add c, is the same as a plus adding b plus c first, or multiplying a times b and then by c, or multiplying b times c and then by a. So the associative property allows us to group terms or factors in any manner we wish without affecting the results. So when you add three numbers, the order does not affect the result. At the same token, when you multiply three real numbers, the order of the factors does not affect the result. Again, it seems obvious, but there are certain things in mathematics where this is not necessarily true. Then the identity properties, 0 and 1, and that is for a real, if there's a real number 0, such that a plus 0 equals a, and 0 plus a equals a. And the real number 1, there's a number 1 that a times 1 equals a, and 1 times a equals a. And again, that may seem obvious, but it needs to be stated because we use these properties in various circumstances. So 0 is the identity element for addition. In other words, we add 0 to a real number, that will always yield that real number. and the number 1 is the identity element for multiplication. Multiplying a real number will always by 1 will always yield that real number. Then we already discussed the inverse properties. So here we have the inverse property of addition called the additive inverse. So when we add a and its additive inverse, we get 0, and also when we add the additive inverse to a, we get 0. So that's the inverse property for addition. Then for multiplication, for each non-zero real number a, there's a single real number 1 divided by a, such that the product of a and 1 divided by a equals 1, and 1 divided by a times a equals 1. So it's called also the multiplicative inverse or reciprocal. So 1 divided by a is called the multiplicative inverse or reciprocal. And I'm sure you've heard these words before, so it's just a review basically. And then there's the distributive property of multiplication with respect to addition. And that is really important too in many instances when we want to eliminate parentheses. So for example, a times b plus c is equal to a times b plus a times c. And again, if you multiply on the right, b plus c times a is b times a plus c times a. So this distributive property allows us to express certain products as sums and certain sums as products. And you're supposed to be familiar with all of these properties, so make sure you have a good understanding of them and know how to apply them. So let's apply this knowledge to the properties for each of these exercises here. Identify the property illustrated by each statement. So 6 plus 9 equals 9 plus 6. That, of course, is the commutative property of addition. The order of the terms, the addends, does not affect the result. And number 48 is the commutative property of multiplication. Again, the order of the factors does not affect the result. Number 49 is the additive inverse property. A number plus its additive inverse is always equal to 0. And here, number 50, 12 plus 0 equals 12. Here the number 0 is the identity element for addition. There would be this property here. Identity element for addition is 0. And for 51 is 9 times 1 equals 9. Here the number 1 is the identity element for multiplication. For number 52, minus or 1 divided by minus 3 times negative 3 equals 1. So here we have the multiplicative inverse of minus or 1 divided by minus 3. That is equal to negative 3. So the product is equal to 1. So this is a multiplicative inverse of negative 3. Number 50, we have the identity element for addition. 0 plus 283 equals 283. It's the same number. Number 54, we have the associative property of multiplication. In other words, the order of the factors 3 times 5 times 4 gives us the same answer as 4 times 3 times 5. And here again, the associative property of multiplication, 6 times 4 times 2, is the same as 6 times 4 times 2. 0 equals minus 8 plus 8. We have the additive inverse. Minus 8 is the additive inverse of 8, so the sum is always equal to 0. And the statement 19 times 12 is a real number is the closure property of multiplication. In other words, that result, that product, is a real number. So that's an example of the property of closure property under multiplication. And number 58, 90 plus 12 is a real number. Again, that's a closure property of addition of real numbers. Here we have the associated property of addition. 7 plus 2 plus 5 is the same as grouping it differently, 7 plus 2 plus 5. And number 60 is the distributive property, 2 times 4 plus 2 times 3. And number 61 is also the distributive property, 9 times 6 is equal to 9 times, plus 9 times 8 is equal to this expression here, multiplying 9 times 6 plus 8. So in both cases, we have the distributive property. The last part is about applications of signed numbers. And so here's how we determine the change from A to B. Suppose that A and B are real numbers. The amount without regard to sign of change from A to B is given by the absolute value of A minus B, or equivalently B minus A. And the change is interpreted to be positive change when A is less than B, and it is a negative change if A is greater than B. And of course, if A is equal to B, there is no change. And to apply this principle, let's look at an example. Here we have company profits and losses in graph form. The graph shows profits and losses for a private company for the years 2013 through 2017. Use subtraction and absolute value to determine the change in profit or loss from one year to the next. Give your answer as both a signed number in thousands of dollars and a word description. So here's the graph of the company profits and losses in thousands of dollars. And so here above, of course, would be profit, and then below the line 0 would be the losses, with the numbers with a negative sign. And so there are 4 exercises from 2013 to 2014, from 2014 to 2015, and then from 2015 to 2016, and from 2016 to 2017. So for A, for 2013 to 2014, so for A we have the difference between minus 142,000 and minus 225. That's equal to $83,000. But because minus 142 is greater than minus 225, it's a decrease. So in other words, the answer is a decrease of $83,000. And for the B part, we have minus 225 minus negative 185. And so that's equal to 40. And because minus 225 is less than minus 185, it's an increase. An increase of $40,000. And for C, we have minus 185 minus 77. So that's equal to minus, that's equal to 262 rather. 262. And because minus 185 is less than 77 rather, it's an increase. So in other words, an increase of $262,000. And for D, we have 77,000 minus 124,000 is equal to 47. And because 77 is less than 124, we have an increase of $47,000. So an increase of $47,000. And this is the end of section 6.2.